Well, hello and welcome to another short Digital++ video. In this video series, we are taking a close look at Gaia, my generative AI assistant that I built on Unity. In this particular video, I'm going to show you the architecture of Gaia and shine some light on one particular aspect of it called function calling. So let's roll up our sleeves and get into the weeds. And here's a high-level overview of how this mechanism works in AI systems. The LLM, or large language model, let's say this is your regular ChatGPT or Gemini AI. It receives your question, which is the prompt, and it determines that it needs certain information to be able to answer your question. It then calls the tools it thinks it needs autonomously, and it uses those results to provide context for your prompt. You can virtually add any tool to the LLM, and later we will briefly see how that works. So you might be wondering, how does a Unity NPC manage all these data streams? And that brings us to the Gaia architecture. We'll go into the architecture much deeper in future videos, but for now let's have a quick look. At the heart of Gaia is the message bus. Think of it as the central nerve system. Instead of every component being tangled together, they now communicate through messages and interfaces, and every component can talk to any other component. Each of the blue boxes in the diagram are Unity components. They're connected to the message bus, subscribed to specific message types. All components on the message bus can send and receive messages. The components interact with the end user device, for example by means of a camera, microphone, a button on the screen, opening an app on the device, control the looks of the expressions of the avatar, whatever. The components are also able to connect to a specific cloud service using an API. Most of the time this is a REST API, but it could also be another API like a database connection. By far the most important component is the LLM component. That's the central brain behind all of this. When the LLM sends a function call, the LLM component translates that into an appropriate message bus message and then sends that onto the bus. The targeted component is subscribed to that specific message and will respond by sending its response back onto the bus. The LLM will then in its turn receive that message, convert it back into something that the LLM understands, add it to the conversation history, and then send it to the LLM. In future videos we will see more on how this works in detail. Now let's see how this works under the hood. I'm switching over to the Unity editor. So for this setup I am using a local Ollama AI server that runs the LLM on my local laptop. You can imagine that is much slower than a commercial AI service, but it has the advantage that it doesn't have any usage costs, nor does it have any rate limits. So first of all, in my project I will need to configure the Ollama LLM. So let's add a component here. I'm going to select the LLM Ollama Vision. Then I need to select which model I'm using. Well, I downloaded GPT OSS 20B, so add that. I need to add a device orientation manager. We'll come back to that in a later video. A quick note about the setup. Here on the left side you will see the Ollama console, and every time the LLM responds you will see a line appear here. On the bottom here you will see the console of the Gaia application, and you already see that it's starting to send some messages around. And the messages you can recognize between the square brackets. Let's start with a very standard question that doesn't need any function calling. Hello, who are you? You see that the speech-to-text service has now transcribed my text, and it has sent it to the LLM. And now we have to wait here in the LLM server panel until we see a response, and the response will then be sent back to the text-to-speech service and then will be spoken out. There we go.
I'm Gaia, your friendly AI assistant. I'm here to help you with information, tasks, or just a chat whenever you need. Feel free to ask me anything or let me know how I can assist you today.
Cool. There's a couple of messages going around in the background. The LLM has received the message here and it's sending it on to the text-to-speech service, and this is the text that was spoken out. Okay, so now let's ask a question where we need more information, like what is the weather prediction, right? So let's see how that works. What is the weather prediction for tonight? And we're going to do a couple of jump cuts.
Temperature in Jan 2026, expect patchy rain in Spitalfields with a 92% chance of precipitation. Temperatures will hover around 37-44 degrees Fahrenheit, 37 degrees Celsius, wind 7-8 miles per hour, and light showers likely. Keep an umbrella handy.
Okay, great. So let's quickly see what happened here. My speech-to-text service has transcribed my question, which is what is the weather prediction for tonight? you see a couple of messages coming in here. We can ignore those. And now the LLM service has sent a message to the weather component to get some information for the weather. And then the weather service responds to the LLM service with the weather forecast. And you see here, this is quite detailed weather information. And then the LLM service uses that information to combine it with your original question, what's the weather prediction? And it now comes back with a response. Tonight, it's a patchy rain, blah, blah, blah. So now you're seeing that the LLM has autonomously made a number of function calls to get information about my current location, about the weather, and then send that back to me as a spoken text. Okay, so let's have a look at the differences between normal prompts and function calling prompts. And we do that by looking at the structure of the JSON files that we are sending to the LLM and that we're receiving back from the LLM. Now here's an example of a JSON prompt. So you send a message to the LLM and that takes place via an array, right, of different messages. Each message has obviously the content, so your name is Gaia, blah, 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 and it has a role. So the first one is always the system prompt, and the content of the system prompt is shown here. Then the user asks a question. Hello, how are you? Respond in English. Then the LLM, which has the role assistant, responds with, hello, how are you today? Then the user asks another question, etc., etc., etc. So here you have the conversation. Now let's look at function calling. We still have an array of messages here with role system, user, and we have role assistant, but you also see another message here of role assistant, which contains a field called tool calls. Where do these tools come from? Well, there's another array that we sent with each prompt, which defines which tools the LLM has access to. So for example, there's a tool here that defines how to get weather information. And there's a description here, what the tool does and what the parameters are. Obviously, it expects a location here. There's also a tool that, for example, gets the top links from the Google Web Services, or a tool that actually gets the content of a Google Web Service, etc., etc. So each of these tools are being defined. So the user asks, I want to see a weather prediction for tonight, in particular the temperature. Then the LLM identifies, okay, for weather prediction, I now need to call a tool that gets me weather information. And this is the argument that I need to send. I need to have the location, and the location is London. The service responds with the actual content of that weather prediction. So this here is the response of the tool that is being sent back to the LLM. The LLM, with role of assistant, creates a response which is then sent back. This is how a non-function calling JSON looks versus a JSON that has the function calling definitions. And that is it for this short video. If you liked the video, you can help me by liking or subscribing to my channel. A slimmed down version of the project is available on my GitHub. It's open source. And I'd also love to see you on my Discord server. There is where you can drop your questions, which I will then try to answer to the best of my knowledge. Thank you very much for joining. Hope to see you soon in the next video. Bye bye.